Good morning, all of you. I Rupak Kumar, IT from IT department. So we are just continue with this last scheduling in a DBMS. So we just see the part one of scheduling lectures. Now we start the part two of the same. Continue from that scheduling. So as we know, the scheduling is very important topic in a database management system. So if we talk about schedules, something which is in a serial and non-serial. We already discussed this topic in last class. So now we just talk about, just take a review of that difference. What is difference between serial and non-serial schedules? So if all transactions executed one after another, means one transaction executed, another executed, then another executed. This is what in a serial manner. Means a transaction T1 executed some process, they completed, they committed, then again transaction T2 started. This is what the serial. And if you talk about non-serial, there is a transaction T1 executed something, then again T2, then again T1. This is non-serial schedule. This is an example we already discussed in last classes. Next point is that no concurrency allowed. There is no any concurrency types of thing in a serial schedule, but there may be a concurrency in a non-serial schedule. So this is what second difference. Third is your less resource utilized and CPU throughput. Means as they have to wait, CPU have to wait for the completing of this transaction. So this is what the less utilization of CPU. In this case, there is no any waiting time. They are just, if there is anything waiting for this, another transaction start some work. So there is no any waiting. That's why it's improved the resource utilization. They utilize full CPU time. So it gives a less throughput and it gives a improved throughput of the CPU. We utilize a whole data, whole time stamps of that our CPU. So we can say as it is less utilized of CPU and throughput, that's why it's a less efficient and it is a more efficient. Non-serial is more efficient. There is no any story of serial thing. So this is a more efficient. There is no any further type. Schedule is serial and serial. So nothing is division. But in non-serial, if it is non-serial, it is out of two type. It may be a serializable or non-serializable. Clear? So now next we have a, if we talk about non-serial schedule, we have a first is your serializability. So we how we come to know what is serializable. So only non-serial schedule need to be checked for serializability. If there is serial, there is no any concern of serializability. But if we talk about the non-serial things, then we have to check either it is a serializable or not. So serializability is checked only with this non-serial schedule. Clear? Next is non-serial schedule is called serializable schedule if it can be converted into a equivalent serial schedule. How we check the seriality? Only if they are just converted to a serial schedule, it's equivalent serial schedule, or we can say result of serials and non-serial schedule is same, then only we can say it is a serializable. It means a non-serialized schedule is called a serialized schedule if it can be converted into its equivalent serial schedules, or results of serial and non-serial schedule is same. If the result of both serial and non-serial come to the same. Next is your serializability. Identify the correct and non-serial schedules, and that will be maintain the consistency of database. So it is important to maintain the consistency with the help of this serializability identification. So serializability identify correct non-serial schedules, and that will be maintain the consistency in a database. Next we can say converted by using conflict and view schedules. How we just convert these to a serializable with the help of these type conflict serializables or view serializable schedule. So if we see in these transactions, this is one transaction, this is one serial schedule, This is another non-serial schedule. We may convert these non-serial schedule to a serial schedules. Then this non-serial schedule is converted to a serial schedule, and this is called what? The serializability. Means we are just converting our non-serial schedules to a serial schedules. So this is process is called, this conversion of non-serial schedule to serial schedule is called serializability of this transaction. How we convert? This is in a non-serial manner. We just move this data item. As it is divided into two categories, conflict and view. So first we come to know what is conflict serializability. A schedule is called a conflict serializable if after swapping of non-conflict operations it can transfer into a serial schedule. Means we come to know what is the conflict operations in serializability. So there is three types of conflict operations in serializable. If we talk about conflict serializability, we have a three conflicting pair over there. What is this conflicting pair is? Conflicting pair is very important. You must have to know. Read and write. If there is a read and write operation in the same data item, and it is called a conflicting. First conflicting pair is read and write. Second conflicting pair is write and write. Third conflicting pair is write and read. This is what the three conflicting pair in this transaction. Read write, write write, write read. But one thing is that it must be on the same data item. Data item must not be changed. So we must learn or remember the things. Three conflicting pair over there: read write, write write, and write read. But we see one thing to remember: there is always a write operation in all these three conflicting pair. Write item is present over there in this conflicting pair. Clear? So this is what the conflicting pair. We must have to remember this conflicting pair for this. Next is your, in this transactions we have a in this schedules we have a transaction T1 and T2. T1 read A, again write A, T2 read A, write A, T1 read B, write B, T2 read B and write B. This is what the non-serial. They are just in a zigzag manner. Now we have to find these conflicting operations. So these two operations, what is conflicting operation? So the two operations become conflict if all conditions satisfy. Condition, which condition? The condition is that both belongs to a separate transactions. Both transaction T1 and T2 belong to a separate transactions. They have a same data item. They work on the same data item. Clear? Next is your, they contain at least one write operation. These are the conflicting operations. That is what conditions that satisfy. Both belongs to separate transaction. It must be on separate transaction. It must not be in a same transaction. T1 but no, must not be there. That must be T1 and T2. Here, that is what belongs to separate transactions, and they have the same data item. The data item is always same. A, then A only. If we talk about B, then B only. Data item must be same. Next, they contain at least one write operation. You see here it is now. How to check whether the schedule is conflict serializable or not? So step first, find all the conflicting pair. We have to find all these conflicting pair in the given transactions. Second step is to draw the precedence graph. This is what the precedence graph. So start finding the conflicting pair. Here it is written. For remember, we have a read write, write write, and write read. So start from reading of A. Then reading of A is here. Then writing must be some another. Writing of A must be in some other. So there is no any conflicting pair in this. We must have to go line by line. We just complete this line. Now come to this reading of B. So there must be writing of B in this, another, not the same in T2 and T1. So there is no any writing of B. No? This is also not a conflicting pair. Next, reading of A. In reading of A, then there must be writing on A. Yes, there is writing of A. Reading of A is conflict with this writing of A. Reading, writing conflict. So we write here in transaction T3 reading operation, and then in transaction T1 we have a writing operation. Just write the conflicting pair over here. Next, we have a in next transaction. Next, we have just come to this. We have a reading of B. Then we must have a writing of B in both or in this. So yes, we just find the writing of B some other transaction, that is what here. So writing of B. So right here, this is also conflicting pair. In T2 we have a reading of B. In T3 we have a writing of B. Clear? Next is your reading of C. So there must be writing of C. So T2 and T1 is transaction. T2 reading of C, in T1 writing of C. Clear? Next, it is also completed. Now writing on B. Writing on B must be reading of B. So there is no any reading, so leave it. Next is writing on C. There must be reading of C. Reading of C. This is what the conflict pair. So write this conflict pair. Or it is also conflict with W. Clear? So we find all the conflicting pair in this transaction. We just erase this so we can see it easily. Erase all. So this is what the conflicting pair we find with this, with the help of these three conflicting pair: reading, writing, 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 read. So we find the 4 conflicting pair in this schedule. Yes, clear? Now draw the precedence graph. How we draw precedence graph? We have to draw the precedence graph by writing only. We write T1, T2 and T3. Write this transaction. We write T1, T2 and T3. If there is T4, we have to make T4 also. But here is T1, T2 and T3 only. So we do not have to draw next T4 transaction. We talk about this. Now start seeing that T3 to T1 is conflict. T3 to T1. So draw a straight line from T3 to T1 and arrow mark from T3 to T1. Next is your T2 to T3. T2 to T3. Start drawing straight line, arrow mark towards T3. Next is T2 to T1. T2 to T1. This is what the next conflicting pair. Now T2 to T1. T2 to T1, no need to draw again. So this is what we find. This is what we find the precedence graph with the help of these conflicting pair in this schedule, in this given schedule. So this is what the conflicting pair, and this is what the precedence graph. Clear? So in this precedence graph, no loops or cycle present in a graph. Loop cycle means this is what the loop. It may be loop like this: T1, T2, T3. If there is something like that, arrow mark from this and this and this. This is also loop, and it is also not a conflicting serializable schedule. But there is no any loop like thing, na? This or it may be this. This is also one of the loop. No, this is not this one. This is one. This one also one of the loop. This is one of the loop. So there must not any be loop. So no loop cycle present in this graph. No any loop and cycle. So schedule is conflict serializable. How to find the schedule is conflict serializable? There must not be any loop present, loop or cycle present in the graph. Then we can say schedule is conflict serializable schedule. I think clear. What is conflict serializable? To find the conflict serializable of any schedule, any given schedule, we have to first calculate or find the conflicting pair in this schedule, conflicting pair between the transactions. So we find the conflicting pair over there, then we draw the precedence graph with the help of these conflicting pairs, and then we have we can find that schedule is conflicting serializables. Now we can just convert it to conflicting serializable with the help of this conflicting pair rules. We have to remember the rules over there, we have to remember the steps over there, find all conflicting pair, draw all the precedence graph in this. Clear? Next is your how we find the conflict equivalent serializable examples. We take an example of conflict equivalent serializables. So it is given schedule S and S dash is given, then find out that if S equals to S dash, then conflict equivalent of these. What is the conflict equivalent of these schedules? According to rule, we have to find the conflicting pair in this. So we can see the conflicting pair over this is that we have a reading of A and reading of A. We can see reading of A in this, and we have a reading of A in this. Clear? So reading is not a conflict pair. So we write second is your reading of A and writing of A. Reading of A and writing of A. In this transition, so we write reading of A and writing of A. This is what the in a conflict pair. Again we have a writing of A and we have a reading of A. This is also one of the conflict pair. Next we have a writing on B, writing on A and writing on A. Write is also conflict now. This is what writing on A and writing on A. This is what also the next conflicting pair. But in this case we have a writing of B, reading of B and reading of A, no conflict. Writing of B, reading of A, no conflict. Reading of B and writing of A, no conflict. Reading of A and writing of B, no conflict. So only 3 conflict pair is found in this. We have a 3 conflict pair: reading of A, writing of A, writing of A, reading of A, and writing of A and writing of A. Write. We have a read write and write conflict pair in this. Now step 1, check the adjacent non-conflict pair as per rules. Next, if present, then swap it. Now where the conflicting pair is over there, in this we have to swap this transactions, means there is a conflicting pair, so we just swap this transaction, means we just move this transaction like it is moved to upside downside. Now this transaction is changed to this comes to this position and this comes to this position. Again another pair is this is here and this is over here. Now it is also a conflict. We just move this to upward and this is downward, and we have this transaction over there. Now this S dash is converted into, now see the conflict equivalence of these schedules. S dash, these both are same now, so hence S equals to S dash, it is a conflict equivalent. So this is what the how we find the conflict equivalent serializable. This is examples of conflict equivalent serializable. So what is the step? We must have to check the conflict pair, that is over there. So first step to check and adjust the non-conflict pair as per rules. So we just see the non-conflicting pair and this rule, and then next is your if present, then swap it. Okay, so this is all about your conflicting equivalent serial schedule. This is what the example, and thank you. In next series we just continue the next view serializables and all. Okay, thank you all of you.